Okay, this is section 3.2, page 4. Let's look at this function. F of x is x to the 4/5 power. It's not differentiable at x equals 0. What I want to know is the reason for that a corner, a cusp, vertical tangent, or a discontinuity. So what we need to look at is the slope of the tangent line from either side of 0, or the derivative on either side of 0. I'm going to use the limit as x approaches a of f of x minus f of a over x minus a as my format of the derivative. That's the easiest one for this. So let's look to the left of 0. That's going to be the derivative from the left of 0. That's our notation. So we're going to look at the limit as x approaches 0 from the left of f of x here is just x to the 4/5 power minus f of 0. Just plugging in 0 there. Let's put that work up here. F of 0 is 0 to the 4/5 power. 0 to any power is just going to be 0. So I have x to the 4/5 minus 0 over x minus 0. Okay, this gives me the limit as x goes to 0 from the left of x to the 4/5 over x. And I want to simplify those exponents. This is just the exponent of 1 in the denominator. I'm going to write that as 5/5. And I can think about this as there's a higher power in the denominator by 1/5. So I'm going to rewrite it as 1 over x to the 1/5 power. So it's the 5th root of x. And let's evaluate the limit then. When I plug in 0, there's still a problem. I have 1 over 0. So a constant over 0, you know that gives you plus or minus infinity. We have to figure out if it's positive or negative infinity using the sign analysis. If you think about a number just smaller than 0, and we're going to plug that in. First of all, the numerator is always positive here because it's 1. The denominator then with a negative number, the 5th root of a negative number is a negative number. So this is going to, the derivative approaches negative infinity on the left. Let's take a look at the right hand side. The derivative on the right of 0 is the limit as x approaches 0 from the right of still x to the 4/5 power minus f of 0 is still 0 over x minus 0. The function is exactly the same here. So I'm going to jump all the way to my simplified form. The only difference is my limit is going to the right from the right of 0. So plus or minus infinity again. Let's look at the sign analysis. Numerator is always positive. The denominator now, if I plug in a number a little bit bigger than 0, the 5th root of a positive number is a positive number. So that derivative is going to approach positive infinity from the right hand side. So what do we have? We have opposite signs at infinity. Basically what that gives us is a cusp, because the slope is approaching negative infinity from the left. The slope is approaching positive infinity on the right. That is a cusp. Okay, let's continue with more on differentiability and continuity. We're going to, in this case, we're given a lot of information. We want to sketch a graph of a function that satisfies all these conditions. So we're given a range of the function from 0 to infinity, including 0. F is differentiable at every number except -2, 0, and 2. So we have some kind of issue at -2, 0, and 2. And here's 3 points that, three points that we were given. Derivatives from the left and right of -2 and 2. And these are also derivatives from the left and right of 0. So basically when you work these kind of problems, your plan of attack should be this. 1, read through the problem. Okay? Kind of get an idea of what you have to work with. Second step, you should plot all the fixed points that you're given. This way you kind of get grounded in what you have to work with here. And our fixed points, these are the fixed points that we have. So I'm just going to do a few points in each direction. So I have -2, 0. There's a dot on the graph. 0, 3 is a point on the graph, and 2, 0 is a point on the graph. Next thing you want to do is look at your derivatives. These are slopes of the tangent lines from the left and right. So what we want to do is sketch out slopes of the tangents from the left and right. And what I'm going to do here is I'm just going to put in like little mini segments because I don't want to connect right away. I'm just going to put in little miniature slopes. You'll see what I mean in just a second. So let's start looking at these. The derivative from the left of -2 is -1. So that's saying the slope of the tangent line from the left of -2, very near -2, has to be -1. So that's a slope that's about like that. So I'm just going to put a little mark right there. My slope's got to be coming in about like that, -1. To the right of -2, my slope is +1. So it's going to be this way. I'm just going to put a little mark there that shows my slope has to approach like that. Okay, so I've taken care of those two. From the left of +2, the slope is -1. So I'm over here. Slope of -1 coming in. From the right of 2, my slope equals +1. So it's going to come in something like that. I don't know the rest of what it looks like, but I know at least that part. Next thing I want to look at, looks like from the left and right is 0. This represents the derivative. This is a standard difference quotient. So the derivative from the left of 0 is +infinity. So basically that's saying I'm going to have a positive slope coming in, but it's going to be approaching +infinity. So it's very, very steep. So I'm coming in very, very steep here. I'll just make that as steep as I can possibly make it. And then on the right hand side, the slope is negative, or approaching -infinity. So it's going to be going down this way, but it's going to be very, very steep. So I'm just going to come off of that as steep as I can, just like that. So I've used all my information at this point. All I have to do is connect, and it doesn't really matter what it looks like in between these values. Just keep it simple. So I'm just going to simply connect those, and then on these I'll just continue those on. Okay, I want to check the range is 0 inclusive to +infinity, so I know these are going to go on and on forever. Looks good. What do we have here? This is a cusp, and these are corners. So those would be the reasons that those were non-differentiable points. So the final step that we have here, we do our mini segments. We just want to connect the points in a simple fashion.